Here we go with a Module 2 constructor response, which is about a pattern. And if you haven't honestly attempted this already, please do so now. Alright, so part A, well, they give you this number pattern in these rows, and it says the pattern continues. And then part A asks the very specific question, and please understand what it's asking. What is the difference between the last number in row 5 and the first number in row 5? Well, we don't have a row 5 yet, do we? So it looks like we're going to have to kind of keep this pattern going and figure out what's going to be going on in row 5 so we can answer this question about the difference between the last and the first number in row 5. So maybe you'll notice that in row 1 there's one number, in row 2 there's two numbers, in row 3 there's three numbers, and so on and so forth, right? There's an extra number. As we increase the row, we get an extra number in the row, right? So row 5 is going to have 5 numbers. And I know something I noticed pretty quickly also is that we go 1, 4, 7, 10, 13, 16, 19, 22, 25. And if we kind of go like in that order, in that sequence, I guess, just literally going left to right as we go down, as we go down, we start left to right. We're always increasing by 3. So what's 28 plus 3? We would have row 5 down here with 31, and then 34, and then 37, and then 40, and then 43. So just by writing out all of row 5, we could figure out that the last number in row 5 is 43. The first number in row 5 is 31. And the difference, of course, means to subtract. Keystones seem to like that word and making sure you know that, and they want to test the fact. Do these students know that the word difference means subtract? Well, I guess you better. So 43, if I was going to actually write this down, like if they're going to, and show all your work if they said that. 43 minus, you'd have to write this down. 43 minus 31 should be 12. I don't have a calculator handy right now. I don't know if I desperately need one. So the difference is 12. Final answer. Oh! Something you also might notice as a pattern is as we go down 1, 4, 10, 19, 31, there's also a pattern there. From 1 to 4, that's 3. 4 to 10 is 6. 10 to 19 is 9. So I guess going down as far as just the first number in each row, we increased by 3, and then we increased by 6, and then we increased by 9. So if you kept that pattern going, that is a pattern, it would make sense that we would increase by 12 to get to 31. Down the right edge, when it comes to the last number in each row, we increased by 6. And then going from 7 to 16, that's an increase of 9. Going from 12 to 28, that's an increase of 12. So you would assume, and you would assume correctly, that we would increase by 15 from 28 to 43. So spoiler alert, in parts C and D, I'm pretty sure that might very much come in handy. But anyway, first, part B. Part B talks about writing an equation. Okay, now here's where we get a little bit heavy. So here we go. Wrap your brain around this, please. Write an equation that can be used to find D, the difference between the last number and the first number for any row R. And you see here, they already have it started for you. D will equal, and then somewhere in here there's going to be an R. that tells the story, like the relationship between the row number and the difference between the first and last numbers, like in that row. So we have an equation that's just kind of says that. Okay, anyway, my way I'm going to do is I'm going to set up a table. So we have a row number over here. This is the row number column. And this is going to be the difference between the first and last number column. So in row 1, what was the difference? Well, that was just a 1. So 1 and 1 is both the first number and the last number. So I mean 1 minus 1, because remember, like I just said, well, let me. This number right here is both the first number and the last number at the same time. So 1 minus 1 is 0. Row 2, we're talking 7 minus 4 to be 3. So again, this column is the row number. When R equals 2, D will equal 3. And then when we're talking about row 3, when R equals 3, we got 16 minus 10. So for row number 3, the difference is going to be 6. And for row 4, we got 28 minus 19. That is 9, which is, this is getting pretty predictable, isn't it? I mean, you can almost see a pattern in my table because, I mean, there is one. You probably see it. So when the row number is 5, we got between 43 and 31. And once again, predictably, that difference between the first and last number is 12. So again, here's my table. When the row number is 1, when R equals 1, D equals 0. When R equals 2, D equals 3. When R equals 3, D equals 6. When R equals 4, And to come up with an equation from a table, like I said in a previous video, from 2017 or 2016 or whatever, you only really need 2 pairs for R and D, or X and Y, or whatever your variables are. I didn't really need to make a table this long. I only really needed 2 pairs, all right? Which could literally be written as 1, 0 as like an R, D value. So I got 1, 0 and I got 2, 3. And you can always make an equation just from 2 ordered pairs. I don't even need the 3, 6, 4, 9, or 5, 12. But again, let me say real quick, some of you students are like pretty sharp about just being able to like look at an equation, look at the numbers, think your way through it, and using whether it's common sense or whatever you want to call it. A lot of you can just kind of look at that table, and I can too, but a lot of you guys probably already know what the equation is going to be just by looking at the numbers in the table. And I guess what I'm sort of saying is, what do you do to 1 to make it into a 0? And that same thing, what do you do with the 2 to make it equal 3? And that same mathematics you can do to the 3 to equal 6. And that's kind of what I'm talking about. But let's go through the motions of taking 2 ordered pairs and coming up with an equation. Well, what do we need? We need slope. And so if we do, 3 minus 0 over 2 minus 1, like the change in y divided by the change in x. Or in this case, it's not really a change in y, it's a change in d. And a change in x is kind of like our change in r. So just kind of make that little simple substitution. All right? So again, this is like our m. And so our m is going to be, so 3 minus 0 is 3, 2. So essentially, our m value when it comes to, and again, let me try to make this clear again. Instead of y, we really have d. and instead of x, we really have r. No big deal. But now we know our m is 3. So how can we figure out our b value? I mean, there's a lot of different ways, and I'm going to give you a really clever one at the end of this part. But let's do the whole d minus d1 equals m times r minus r1. That's just point slope form adapted, with our d and our r instead. And again, there's other ways to do this, but here's just the way I'm doing. So we already know that m is 3, and you always leave y as y and x as x, or in this case d is d and r is r. But the coordinates of one point are going to go in for d1 and r1. So I don't know, I'm going to pick, it doesn't matter which one you pick, but I'm going to pick plugging in 2 for r1 and 3 for d1. Is that right? And then just kind of working this out real quick. Because, look, I mean, it's obvious they want the equation with d by itself. You want to solve this for d. And essentially have it in this form, okay? So we just got to finish getting d by itself. Negative 6 plus 3 is negative 3. So the final answer, d equals 3r minus 3. Now I want to point out one more thing. Remember how m is our slope, of course? Well, of course, you really should know, that our b value is our y-intercept. It would be actually very useful for you to remember that when it comes to a table, you can think of your y-intercept, your b value, as being whatever goes with 0. 0, comma, what? And that question mark that hooks up with the 0, that's going to be your y-intercept. So, I mean, just look at this table. 1, 0, 2, 3, 3, 6. If you go back to like 0, almost like take this in reverse, 6, 3, 0, what's going to go here? Well, you're going to see that that's going to be negative 3. So definitely not a coincidence that we ended up with a b value of negative 3. And in your table, you have the ordered pair of 0, comma, negative 3, just by kind of taking this pattern in reverse. Okay? Moving on to part C. All right. What is the first number in row 8? The first number in row 8. Now, we could literally, love to use that word, write out all of row 6, all of row 7, and then all of row 8. But I'm going to use this kind of pattern here to kind of figure out, and I'm going to, sorry, but I'm going to kind of show the work here. I don't know if there's a lot of room or anything, but we're going to have a jump of 15 to get to row 6. And so that gets me to 46. And then we're going to have a jump of 18 to get to row 7. And what's 46 plus 18? I should probably have a calculator. 64. I do declare. 46 plus 18 is going to get us 64, correct? So row 5, row 6, row 7, and then keeping the pattern going, now we're going to make a jump of 21. And that's going to get us 85. Yay. All right. So that, well, there it is, 85. Like, that's part C, isn't it? There it is. 85. Sorry. All right, cool. But then part D wants the last number in row 8. I mean, come on. Isn't this just... This is a little excessive at this point. This is unnecessary. So, here we go. Keeping this pattern going, see how clever we are. We're going to make a jump of 18 over here. Where's the color? Oh gosh, 43 plus 18. 61. Right. And then making a jump of 21 to get to row 7. That's going to get us to 82. And then finally, we're going to make a jump of 24 to get to 106, right? And that, so let's see here. This was row 5, row 6, row 7, row 8. So that, I mean, I don't know, maybe it actually would have been easier just to, or, you know, less stress or whatever, to just literally write out all of row 6 and then all of row 7 and then just jumping by 3 every time, you know what I mean? But the final answer to part D was at 106. 106. That's it.